Yeah, so still waiting a couple minutes for people to get in. Um, for attendance policy, to make sure that everything goes over smoothly, and I have a hard record of everyone that gets in. If you could send, like some people have already been doing, send a message in chat whenever you start a class with me, and then a little bit before the end, to make sure that I have like a solid record of your being here, because in case I forget, you know, if I accidentally put your name in incorrectly or something, then that way there's a hard record for us to go back and compare, so I can say, yeah, they were definitely here that day. So the idea is the Zoom thing does not record the chat, or it doesn't record the attendance logs by, I think it's just this free trial version doesn't do those things, but it does record the chat log. So as long as I have a chat from you when you get in or when you leave, those get timestamped. So I know exactly when you said you were in. Okay. So one thing real quick, going to check out so first off, I apologize that I thought I had uploaded the tests, but obviously did not. So for now, you do have your 3 tests up. And I extended the due date to Saturday at 5 p.m. instead of Friday, because I was supposed to upload them yesterday morning. So this is, yeah, this is what they look like. Remember that they don't, that they are timed. Let's see, let's go to student view. Let's see. So y'all's will look like this. You have the 3 chances. Remember, the third one is a last-ditch effort. So it is, I think we said it was at 80%. If that's the one that you end up having to use, but you can do all 3, and I'll just take the highest one of the 3 with this reduction. So please do at least one of them, but you do not have to do all of them. So if you get an A on your first one, then you are hold on. So yeah, if you do fine on the first one, you don't have to do the other 2 if you don't want to, but you are welcome to, if you so decide.
Hey, my bad, Doc. I had just seen the link towards the top of my emails. I was looking at the older one.
Yeah, so the way it had been previously set up was it was not doing things correctly, where the it was making me create a new link every time for every class, and that's not how it was supposed to have worked. But I got that figured out. So the link will always be on your Outlook calendar. I don't know if it's under your Zoom, if you have the app. I don't know if it's under your Zoom meetings schedule. I would imagine it is, but it should be on your Outlook calendar if you're ever not able to find it. So yeah, so these are your 3 tests, and the document for that is on e-learning 114 resources, online test overview. So yeah, let's see.
I'm sorry. Where were those tests posted again? I'm sorry.
They're on WebAssign. So this is what my WebAssign looks like. But for y'all, it looks like this. So that just looks like 3 assignments. 3-point test 3.1, 0.2, 0.3. So yeah, so it's the same place as your other WebAssign assignments. Also, with that, since we've had some people come in, the attendance policy is so I can have a hard record of when you got in. You need to send a chat message when you enter and leave the Zoom meeting. But remember that there is usually we usually run right up to the time limit. So just sometime in the last 5 minutes is fine. But yeah, so that's for the attendance. When you get in, throw a message in chat. And then when you leave, get a message in chat just sometime toward the end of the session. Because that's how I'm going to be reviewing attendance records, because the Zoom meeting will record that. Okay. So, all right. So again, that was chapter 5 tests, and we're going to kind of dip our toes into chapter 6, which is just some more trig. I wasn't kidding when I said a lot of schools don't even call pre-calculus pre-calculus. They call it trig because, yeah, there's a lot of trig, and for good reason, but yeah. So the title of the chapter is just additional topics in trigonometry. And we're going to be going over some concepts that are pretty helpful, solving a lot of things that you will see in the future. And the first one we call law of sines. All right. So this is obviously a law that has to do with sines. But it's also something very basic about triangles in general. So let's draw some generic triangle. Don't want it to look like a right triangle because it's not. So I'm kind of making it look extra not right. So we're going to label our, does anybody remember what these corner points are called? Does anybody remember what these things are called?
I'm gonna take a shot at say intersections.
Nope. They are kind of intersections. But
Vertex.
there you go.
Oh, I got it right this time?
Yeah, so you had it.
Perfect.
Yeah, so one of them is called a vertex, and the other ones are called vertices. If they're multiple, they are vertices. So we have this triangle, and the way we usually label generic triangles is the side that is opposite a vertex has the same letter, but lowercase, as that vertex. So this is side A, because it's opposite vertex A, side B, because it's opposite B, and side C, because it's opposite C. Okay. So to prove that two triangles are congruent, there's a couple requirements. Does anybody happen to know what those congruency requirements are to prove that two triangles are equivalent? We call it congruency. So the first guarantee that two triangles are congruent, and I say this is the first one because to me it's the easy one, is called side, 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 or SSS. So if two different triangles have sides that are all the same size, then they are equivalent. There's no way you could make a triangle with the same length sides but different angles. Okay, so if you have a triangle with sides A, B, and C, you took them apart and then you tried to put them back together into a new triangle, you can't make a different triangle. Okay, so it'll still be the same one. It might be like turned or something, but it's still the same thing. You are still you, even if you're sitting down or, you know, standing on your hands or something. So this is what side, side, side congruence is. But there's a couple other ones that deal with their angles. Okay, you could have side, side, angle. So two sides and an angle opposite one of them, side, side, angle. So if you had side C and side B, and then angle B, you could not create a new triangle because I won't go into the proofs today. That's too much for the test out. But these are some of the different congruencies. There's also number 3, which is, I'm not going to write them out anymore, either angle side angle or angle angle side. So any two angles and one side, if they're the same, then the entire triangle is the same. And for side, angle, side. So these are all the possible different congruencies, okay? And the middle two actually correspond to something that we're going to be talking about today, which is this law of sines. So side, side, angle, or angle, angle, side. Okay. So let's look at what this sines. Does anyone happen to know remember what law of sines is or law of cosines is? I mean, it's fine if you don't, but. So the law of sines says that this ratio holds true. A over sine A equals B over sine B, C over sine C. So this is true for any triangle, okay? And this is where those congruencies come from, because they basically fill in these two things and one of these other things. So you can have angle, angle, side, which would allow you to solve for B, or you could have side, side, angle, which would allow you to solve for the angle of B. This is the law of sines. And this also means you can write the law of sines upside down and it's still true, because this over this equals that over that. And it would also be true if you flipped all of them. So you could say sine of A over A equals sine B over B equals sine C over C. So this is the law of sines. And this kind of gets more into geometry because it allows you to get into, it's kind of like the Pythagorean theorem we've dealt with in the past, where if you knew two of the sides, you could find the other one. Well, and you can find all the angles and everything like that. So law of sines is a little bit more complicated, but it's true for all triangles. So if you have these two sides and one of those angles, then you can find that angle. So let's look at this for a second. So let's say we have a triangle. Of side of 28 feet, 29 degrees, and 102 degrees. Okay. So we're going to use this information to find everything else out about the triangle. Something that we kind of did similarly with the Pythagorean theorem and some right triangles, but this is not a right triangle. So what are we going to do? We have to find a, little a, and little c. So who has a suggestion on what I can do to find the rest of this triangle?
I'm sorry, can you repeat that question, please?
So we have this, the length of this side, which is 28, we'll put a unit on there, feet. And we have this angle, which is 102 degrees. We have this angle, which is 29 degrees. So the idea behind this now is we are going to what we call solve this triangle, but it's not a right triangle. So we don't have the same tools we had when we were doing this, I think in chapter 4. So we had some certain tools for us in chapter 4 because we're talking about very special triangles, right triangles. Well, this is not a right triangle. So what can we do? We need to figure out, we're going to figure out all three of these things eventually. But which one do we want to figure out?
The easiest one for me was finding out the angle for A, because I know you said all triangles equal 180, so I just did 102 plus 29 and minus that by 180.
Yeah, so very good. So one of the things we know about triangles is all of the angles have to add to 180 degrees. Well, to find A, that's going to be 180 minus 102 minus 29. And what did you get?
I got 49 degrees.
Sounds about right. So A equals 49 degrees. Okay. So what about now? We still need to find A and C. What can we do for those two? Hint, it might have something to do with this. So the law of sines says that A over sine of A, but what is the angle for capital A?
49.
49 equals B, but we know what B is. It's 28 over sine of what?
29.
What?
Sine over 29.
Mm-hmm. Equals C over sine of what?
2.
What?
102.
102. So, depending on what we want to solve for, this is an equation that has one unknown and 3 numbers. This is an equation that has one unknown and 3 numbers. So if you solve it, we'll solve for this one first. A equals, what do you do with this thing? How do you get this on the other side?
Multiply.
Multiply it, yeah. So you multiply it and it will go up. So you get 28 times sine 49 over sine 29. And I get about 43.6 feet. That one. And for B, I'm sorry, for C, what does C equal? So this gets multiplied up. So you have sine of 102 over sine of 29. And I get that equals, where is that? 56.5 feet. Okay. So this is the idea. It's just a new relationship, a new thing that relates all of the sides of a triangle. So this is something that it's kind of like we used the Pythagorean theorem, where we knew something special about right triangles, and that was that the Pythagorean theorem applies. A squared plus b squared equals c squared. But this is something that's true no matter what. Okay, so this is something that should also work for right triangles. So before we close out, because we got about 8 minutes left, we're going to do this for a right triangle. All right, so So what kind of congruency do we have right here?
Side angle side.
Yeah, so we can't use this. We need something a little bit different. We need side angle. So let's try this. So we can call this angle C is 90 degrees. And this is side C. We can call this angle A, B. This is side B, so this is side A. So we need capital A, capital B, and side little a. Okay, now we're not using the Pythagorean theorem. We have to use the new stuff. So, law of sines. So, sine of B over side B, which is 3, equals sine of 90 degrees over C. So, what do we do? Well, we just multiply it up. We get sine B. First off, what is sine of 90 degrees? Anybody?
1.
1. Yeah. So this becomes 3 over 5. So B equals sine negative 1, 3 over 5. What do I get? I get 36.9.
Can you show me how you got that, please?
You just put it in a calculator.
Okay.
You either do sine negative 1, or your calculator might say arc sine, or you can put it into Google. Just make sure that your thing is in the correct units that you want. It could be in degrees, or it could be in radians, so it'll spit back whatever that is. So that is 36.9. And from there, we have 2 options of finding capital A. Or actually, we only have 1 option, I'm sorry. Capital A has to be 180 minus 90 minus 36.9. So my value for that angle should be 53.1. So A equals 180 minus 90 minus 36.9 equals 53.1. And last but not least, for side A, we have sine 90. Actually, I'm going to do it anyway. We have 5 over sine 90 equals A over sine of 36.9. So do this again, and you get 5 times sine 36.9 should equal about 4. All right. So we've got a minute left in the chat. So give me a see you later, see you Friday, something like that. This is the law of sines. It just says that the sine of an angle divided by the corresponding side is constant for every side angle pair in a triangle, for any kind of triangle. So yeah. So I'm sorry, this is not 36.9. This is 53.1. I'm just in a hurry and made a mistake. Yeah, so make sure to do the test, and that's all we've got. So y'all have a fabulous evening.
Is our test on Senegate?
It's on WebAssign.
WebAssign?